Welcome. So, now that we have decided to go ahead with the review and determined what to include and not to include, then it's time to get started. And the first thing you want to do is to get an overview of your energy consumption, which is done by analyzing historical consumption data, typically anyway. So let's see how you can go about doing this. We'll start by looking at something called a top-down approach, which basically means look at overall consumption of energy from different kinds of sources. Typically, you would get this from invoices from previous time periods. We will see variations over time, so it's a good idea to dig up data from a few years back to make sure you catch variations over the seasons and even the years. The reason why this is important is to understand what factors that have an impact on energy consumption and hence be able to find suitable improvement actions and also determine suitable energy performance indicators later on. The graphs on this slide show how hourly consumption in 2 different months of the year. Many utility companies provide smart meters that record and store energy consumption in short time intervals, which is very useful when analyzing the variation in energy consumption and understanding in more detail how different activities and equipment influence energy consumption. If you don't get this information from your utility, you will have to invest in some sort of meter and install yourself to get this kind of information. As a reviewer, we will need to look at the variation in consumption data and direct questions to production representatives, who will have to explain why these variations exist. And then we will be able to draw conclusions on what activities that are the dominant energy consumers and estimate how much these consume. To explain how this is done, we'll take a closer look at these 2 graphs that come from a sawmill. This is what the power consumption looked like at the sawmill in September of 2015. The 3 lines here indicate minimum, maximum, and average power consumption for every hour throughout the day. As you can see, there's a relatively low base load of about 15 kilowatt. This is the consumption when the plant is not running. The load is relatively low, but it's present all the time. So it's still worth looking at. It can consist of lighting, ventilation, heating, or other equipment that is idling and never turned off. What you need to ask yourself here is whether there is something turned on during nights and weekends that doesn't really have to be turned on. A visit to the plant during nighttime may be helpful here to find such things. In the graphs, you can clearly see how production starts from 5 to 6 a.m. as the power load increases dramatically. Here, it is useful to look at what the difference was between the days of minimum load and maximum load and try to understand why there's a difference. We can also clearly see in the graphs when breaks occur during the day. It appears here, though, that all equipment is not turned off when taking breaks. Next, we take a look at the peak power load. Many electricity customers pay a proportion of grid fee that is dependent on the maximum power load during a certain time period. Therefore, controlling the peak load may very well save quite a bit of money, even though you don't necessarily save any energy. This is achieved by prioritizing consumers during peak load periods and spreading this load out over time. As an example from your home, you might want to make sure that you are not running the dishwasher, microwave, stove, and hairdryer all at the same time. If you can simply spread the use of these consumers over time, you will reduce the peak load, although not necessarily save any energy. In an industrial environment, you might want to install a load monitoring system that can cut off loads of lower priority when you hit a certain level. Now, we had 2 graphs, so let's take a look at the second one. This second graph is from January of 2015, so in the middle of the winter. Here you can see the base load has made a significant jump from about 15 kilowatts to about 100 kilowatts. Also, the peak load is substantially higher at 430 kilowatts compared to about 115 in September. Once you have this data, you of course need to understand the reason for the differences between the time periods. This is explained by certain activities, equipment, or processes which are active in one period but not in the other. By looking at these differences over time and knowing how this is linked to operation of different equipment, we can estimate energy used by the different equipment or processes. If you already have meters on different equipment or production units, then you may already have this information easily available. So you might not need to put so much effort into the graphs. But often this is not the case. So you need to do a bit of detective work, as we've described here. The goal is, however, the same, namely to understand what equipment, processes, and activities that consume most of the energy to make sure that we focus our improvement efforts on the right things. That's all we had on the top-down approach. We can of course turn it around and look at a bottoms-up analysis, which we'll be looking at in the next presentation. So I wish you welcome on that one. Thank you.